Hello. In this lecture, we're going to briefly discuss notions of probability, the calculations of probability, and probability distribution. First, let's look at this concept, deterministic relationship. A deterministic relationship describes a one-on-one numerical relationship between two variables. That is, one variable can generate a certain response from the other variable. For example, in a lab-controlled environment, scientists measure the relationship between the temperature and the pressure exerted by the air mass on the container. They discover that when temperature increases, the pressure exerted by the molecules on the container rise with temperature that can be described with this curve. As you can see, that for a given temperature, the pressure exerted by the molecules on the container is uniquely determined, and thus is what describes this smooth the curve. Okay, so this is called the deterministic relationship. You have this one-on-one relationship between temperature and the pressure. Now, another kind of a relationship is called statistical relationship. For this kind of relationship, the response of one variable to another variable is not unique, is not certain, but uncertain. For example, we have these two variables. On the horizontal axis, we have the income level. On the vertical axis, we have the spending level. For a certain level of income level A, the level of spending from people who earn the same level of income level A, varies. People who earn the same level of income, they spend differently. Some people spend more, some people spend less. So you have a range of spending. You have a range of response from one variable to the other variable. So exactly which one is uncertain. You have a range of values of spending among those people who earn the same level of income. And with increasing income level, in general, people also spend more. But again, even at a higher income level, the level of spending still not uniquely determined, is not certain, but a range of level of spending. And what we hope to find is the relationship between one variable and the means of the other variable. That is, for different level of income, what is the average level of spending of those people? And this kind of relationship obviously involves this uncertain response of one variable to the other variable. And this kind of relationship is called statistical relationship. Statistical relationship. Okay? This form clear contrast with deterministic relationship. Of course, when we say uncertain, response from one variable is uncertain to the other variable, it does not mean that we entirely have no idea what is happening. Through observations, through theoretical thinking and theoretical reasoning, we can really discover some regularities. For example, if you toss a fair coin and to see whether you get the head or tails, you know that if the coin is fair and there's no reason that one side occur more frequently than the other. So this is theoretical reasoning give us a guide regarding the outcome. So not entirely clueless. We have what we call the random relationship. Each outcome has an equal chance of occurring. Now, as we said, you toss a coin, you know if the coin is fair, the head and tail have equal chance of occurrence. And you roll a die to get 1 and 2, 3, 4, 5, or 6, you know each side have equal chance of occurrence. And this kind of relationship we call a random relationship. There's also a kind of relationship, it's called stochastic relationship. A stochastic relationship, and that is not all the outcomes from an experiment have equal chance of occurring. Okay. For example, insurance company, they always go out there to collect data to calculate what is the probability for people involved in an accident, and if they involved in an accident, what is the likelihood that someone got injured, someone got severely injured, or someone even got killed. And the people who got killed, people who are at different age groups will have very different probability of getting injured and getting killed. And young people, especially teenagers, are known to have a higher probability of involved in car accident or even being killed. And men probably are more likely to be killed by women in a car accident. So this kind of a statistical relationship, you really do not see that all the outcomes have equal probability of occurrence. But for random relationship, this is a kind of a statistical relationship where all the possible outcomes have equal probability of occurrence. So there are two types of a statistical relationship here. One is a random relationship, the other is stochastic relationship. Now, we've been using the word probability already. Now, let's formally define this term. Probability can be defined as likelihood that a particular event or outcome of an experiment occurs. And the probability is normally expressed in percentage or in a fractional number. What is an experiment? An experiment is a random process that leads to a certain outcome. Random process, as we mentioned early on, is kind of a process where the outcome is uncertain. Okay, and any process, any random process will lead to some kind of a outcome. This outcome we call an event. An event. This experiment can be a natural event or can be the controlled event. So here we have examples of experiment and the resultant outcome or event. Roll a die can be an experiment. Here is just a pre-post action. It's controlled action. A thunderstorm is a natural process. You can also see that as an experiment. Now the outcome, you roll a die, the outcome to get a 2 or 5 or 6, these are all called the outcome from this experiment of rolling a die. And they are also called event. Getting a 2 is an event. Getting a 5 is an event. Getting a odd number is also an event that relate to this experiment of rolling a die. Thunderstorm is an experiment, and the outcome of thunderstorm may be tornadoes or not tornadoes. So that having a tornado is also an event associated with this experiment of having thunderstorms. Okay. So these are some very basic concepts. Now, when we come to the probabilities, there are three different ways to determine or calculate probability of a particular outcome from an experiment. First, so-called classical approach. The classical approach calculates probability by using the total number of possible outcomes from an experiment divided into the number of ways of a particular outcome occurs. We have this expression, P parentheses an outcome. So this is a way to say the probability for a particular outcome to occur. And this is calculated by the number of ways of a particular outcome occurs divided by the total possible numbers of outcomes that may come out from an experiment. For example, if you toss a coin, the total number of possible outcomes are 2, head or tail. And the number of ways to get a head, for example, is one way. Therefore, 1/2. So that's how we get the probability of getting a head, tossing a coin. Here, in this formula, all possible outcomes are exclusive of each other. For example, getting a head, getting a tail, they could not happen at the same time. So they are exclusive of each other. Okay. Also, each possible outcomes of the experiment has an equal chance of occurring. Getting a head, getting a tail, as long as the coin is fair, is equal. Okay. The chance of getting a head or getting a tail are equal. Now let's practice a few questions to practice how do we calculate probability using the classical approach. One trial refers to the experiment. We conduct the experiment once. Toss a coin. What is the probability of getting a head? Now, the total number of possible outcomes is 2, head or tail. The number of ways of getting a head, just 1, so 1/2, 50% or 0.5. So we have a different way to express probability, a fractional number, a percentage, or a decimal number. Okay. Roll a die. What is the probability of getting a 5? When you roll a die, the total number of possible outcomes is 6. And how many ways you got a 5? Just 1. So 1/6, or 16.7%. You draw the card from a deck of playing cards. The probability of getting an ace. In a deck of playing cards, you have 52 cards. So you have 52 possible ways of getting a card. How many ways you can possibly getting an ace? 4. So 4/52. So 7%. Okay. 2 trials. You conduct an experiment twice. Now toss a coin twice. What is the probability of getting 2 heads? Now we just use this classical approach. The classical approach is at the bottom is the total number of possible ways, total number of possible outcomes from this experiment of tossing a coin twice. On the top is the number of ways of getting the results involved. Okay. Now you will get 2 heads. So let's use this visual device to help us to think through this problem. You toss the coin twice means you toss the coin once and see what you get. Then you toss the coin the second time and see what you get again. If you get the head the first time and get the head the second time too, and that's the event that you are looking for. So you want to find out what is the probability of getting two heads. Now let's see, in the first round of tossing, you may get a head. You may get a head, or you may get a tail. So that's the two possible outcomes from the first round of tossing a coin. Now let's do the second round of tossing. If you get a head the first time, second time you can still get either head or tail. And if you get the tail the first time, the second time you can still get either head or tail. Okay? Now let's summarize the result after the two rounds of tossing a coin. We summarize to see that what are all the possible outcomes when you toss a coin twice. If you get the head the first time, second time also get head, so you have this head and head. If you first time get a head, second time get the tail, so you would get head and the tail. Another possibility, another possible outcomes. And another outcome is that if you first time get a tail, second time get a head, you would get head and tail. So that's another possible outcomes. Last outcomes is that you get the tail the first time and get a tail the second time. So tail, tail. So these are all the possible outcomes if you toss a coin twice. So this is the number that should go to the bottom. Now, after that, we have to decide how many possible ways we got two heads. How many possible ways we get two heads? One. And this is the number that should go to the top. 1/4, 25%. So the probability of getting two heads up when you toss a coin twice is 25%. So this is a 212. When you calculate the probability by using the classical approach when you deal with 212. Okay. So the roll the die twice, what is the probability of getting at least 1/6? For this question, we dealt with this question in class activity, so you can go to watch the videos on the calculating probability. So we don't spend more time here. We have exactly the same question that is discussed there. Okay, so you can go to watch that movie. Now we have a couple of concepts here. The experiment with replacement and experiment without replacement. The experiment with replacement is that if you conduct an experiment more than one time, okay, you draw a card, for example, from a deck of playing cards. And after you see what you get, the first time, before you draw another card from the deck, you place the card you draw back into the pool and draw another card from the deck of playing cards. This kind of experiment is called experiment with replacement or sample with replacement. So you draw an item from a pool and you see what you get. Before you draw an element from the pool again, you put it back. When you do this, the probability of getting a certain item in different drawings will not change. They are the same. We call this the probability of different drawings are independent of each other. Between different drawings, the probability of getting something, getting the same thing, is the same between different rounds of drawing. Because every time you go to draw an item, it is the same pool. It's the same pool. Therefore, the probability of getting the certain outcomes should be the same. Now, experiment without replacement or sample without replacement. That is, if you draw an item from the pool, when you go in there to draw the second items, you do not place the items that you draw the first time back into the pool. Therefore, the number of items changed, and the composition of the items will also change. Therefore, the probability of different drawings are not the same between different rounds. So we said that they are not independent of one another. Think about if you draw a card from a deck of playing card. You got ace the first time, and then you're going to draw another card, but without placing the ace that you draw the first time back into the deck. Therefore, the second time when you go to draw this card, draw a card, the number of cards changed. Now it's only 51 cards, and the number of aces also have changed. Now there's only three aces, and therefore the number of items changes, the composition of the cards changed. Therefore, the probability of getting an ace is also changed. So this experiment with or without replacement will have a large impact on the outcomes of